morning. Exponential function. For any real number x, exponential function is any function of the form a times b to the x, where a is any non-zero real number, b is any positive real number that's not 1. This is going to be plots for b to the x. Letting b go from 2 to 20. I'm only going to look at the integer values. Now wait, why is it not showing? There we go. And so notice what the graph is doing as the value of your base gets larger. It's hard to see here, but this is getting closer to the x-axis, and it just stopped. Why did you stop? This part gets steeper, right? So the rate at which it's increasing is going up. But notice the y-intercept is not changing. It's always passing through the same point on the y-axis. Obviously, domain's not changing, and the range isn't changing, right? Just looking at the graph, what's the domain? You gave me half of it.
Negative infinity times 0. Negative infinity comma whatever number you said. Got it here, but you know, just say what you said with the negative.
Wait, you said domain range.
Domain.
Wasn't it just negative infinity comma, including 0? Or whatever's touching the y-axis?
Negative infinity, whatever the number is that it restarts at 2.
And this just goes on forever.
Oh, so it's negative infinity.
Domain's everything, right?
Okay.
Again, it's hard to see because of how quickly it's increasing. But if I extend this out, this is just going to keep going up and up and up and up. I'm going to need a very large y value to actually see the x equals 10 here. Right? Especially for 20. What's 20 to the 10th power? A very large number. What's the range?
Range is 0, infinity.
Is 0 included?
Yes. But no, because
Which means x equals 0 is what?
x equals 0
That line is called what?
is minus root. The y, the x.
When a function starts to level out to, what is it called?
Horizontal.
It's a horizontal asymptote. So 0 is a horizontal asymptote for this function.
So you don't have to have another line, a graph or whatever, to show the other line.
No. So for horizontal asymptote, it just has to be one side. Right? It has to approach the value just on one side. In this case, happens to be the left side. I'm going to use these for the values less than 1, a half, third, fourth, fifth, right? So I'm just going to increase the denominator by an integer each time. Kind of the easiest way to look at it, but again, you have like 2 raised to the x. Right away, you can tell the difference, what happened. So what mathematically is that called?
Reflection across the y.
So it reflects across the y-axis, which makes sense, right? Because I wrote it as b to the negative x. Writing it as 1, well, actually I probably could have done 1 over b to the x. Actually probably would have worked. It's still going to do the same thing I want it to do. So let's see what happens as we let b increase. Which means the 1 over b is getting smaller, right? If I'm letting b get larger, the 1 over is going to get smaller. Same thing, right? Except it just reflected. So again, it paused. Why did it pause? Thank you. You can't see it, but this is getting closer and closer to the x-axis. Obviously, you see that this is getting steeper and steeper. Still passing through the same point on the y-axis, which happens to be the same point as for b to the x. And I'll actually do both graphs on the same axis, and we'll see that. Domain is what? Still all real numbers, right? Range is what?
The infinity or 1.
Not including 0 on infinity.
Right. Not, you said open, right? Not including, right? Still 0 to infinity, and then x equals 0 is still horizontal asymptote. So whether b is larger than 1 or less than 1 doesn't change any of the properties, other than reflex. Right, so the pink one is for b larger than 1, green one is for b less than 1. And again, you see they do cross the y-axis at the exact same point. That's what makes mathematics so cool. A would be your initial value. Now, if you take any non-zero real number and raise it to the 0 power, what is it? A lot of the models that we use the exponential function for have to deal with growth and decay. So obviously our exponent would represent time. That's why we call A the initial value. T equals 0 represents starting point, initial. B is your base. So this is the exponential function base B. You're already familiar with one of the bases. You're probably familiar with more than one, but one definitely. It's called the common base. What base do we think that is?
10.
Base 10. That's what our decimal system is based on.
What base 2?
Base 2 is binary.
Is that like?
That's for computer language. Well, actually, what are they up to now? 128-bit?
I know it's 60. I don't know when it's 60.
Yeah, I think it's 128-bit. 64-bit is on every computer.
Yeah.
They're usually,
Go past
it's usually one above that.
it. Okay.
So since 64 bits extremely common on every computer, I think they're up to 128-bit right now. They just haven't optimized it for every day. Right, so that'd be base 128. Right, but you do see binary a lot in computer language. Right, those are the bits 0 and 1. Hexadecimal is also another very common base you see in computers. That's base 16. But really, any power of 2 can be used in computer language. Like I said, I'm pretty sure that's 128-bit right now, operating system. That'd be base 128, which is 2 to the 7th. That's pretty good. However, that's not the most used base in mathematics. That base is called the natural base. Base E, and we'll look at that shortly. All right, said domain of F, all real numbers. Range 0 to infinity if your A is positive. Negative infinity to 0 if the A is negative. Y-intercept at 0, comma A. Was on last asymptote, y equals 0. Again, as we just saw, all of these properties are for any possible base B. That's allowed. Right. The reason we don't have 0 and 1 included, 0 would be really boring. First off, wouldn't be defined at 0. 0 to the 0 is indeterminate. But everything else would just be 0. So that's pretty boring. Same thing with 1. 1 to any power is 1. So that's a pretty boring function. That's a constant function. So that's why we exclude those two bases. Exponential growth. All right, so this is just kind of real basic right now. This isn't actually how exponential growth is defined for that you need calculus. So a function models exponential growth, grows by a rate. So this is the actual definition. Its rate of growth is proportional to the amount present, but rate of growth is a derivative. So you'd actually need calculus. Actually, you need differential equations. That's where you learn to solve differential equations. Things like a rate of growth equals something. That's a differential equation. If you will, Calc 4. So, with all the techniques, any number x and any positive real number a and b such that b is not equal to 1, exponential growth function will have the form of a times b to the x. Right, you can get that from the techniques of differential equations. Where a is your initial starting value, b is the growth factor or the growth multiplier per unit of x. Even though a lot of things follow exponential growth. Population growth is generally an exponential growth function. So that also includes, like if you're doing biology, bacterial colonies, that's generally a growth. That's generally an exponential growth factor. We also have decay. Right, so instead of growing, it's just decreasing. Radioactive decay is exponential decay. And of course, you can use one of the applications of radioactive decay is carbon dating. However, the one that interests me the most is compound interest. This is an exponential growth function. Compound interest is just an application of simple interest. So the simple interest formula interest rate times principal balance. That's simple interest. Right. Not very common in everyday life, simple interest. Let's just say you happen to find a bank that uses simple interest. Take out $500,000 for a mortgage. And they say that their interest is 30%. I'm using such high number because it's simple. Then the interest that you pay on the entire mortgage is just 30% of 500,000, which is what? 10% of 500,000 is 50 times 3, 150. So your total mortgage that you have to repay would be $650,000. No, you're paying $150,000 interest. That would be simple interest. Regardless of how quickly you pay it off, that's your balance, $650,000. Again, that's not realistic. Because it's always compound. It's not really compound in the sense of mortgages. It's kind of reverse, right? You pay down your principal, obviously the interest you pay that period is less because there's less principal. But if you don't pay it, your principal goes up, so now you're paying more in interest. That's the idea of compound interest, is that you're gaining interest on the interest. Right? Each period, your principal is the previous principal plus the interest earned. So now you're gaining interest on a higher principal amount. I believe I went through the derivation in the video, so I'm not going to re-go through it, but you'll wind up with compound interest formula, A of t equals P times 1 plus R over N, all raised to the NT. A of t is the account value after t periods. Usually t is in years, so after t years. Yeah, t is measured in years. P is the starting amount of the account, often called the principal or the present value. R is the annual percentage rate, the APR, expressed as a decimal. And N is the number of compounding periods in a year. And depending on the situation, you may also see APY, annual percentage yield or average percentage yield. Bonds would follow this model. Savings accounts would follow this model. Of course, bank savings accounts are absolute garbage. And they were like, oh, open a savings account, you get 0.25% APR. Whoop-de-doo, I get 0.25% a year. I'm better off just throwing that into a stock market. I can do way better. On average, about 20% return every year on my investment accounts. Wish I had money in 2020. I would have like quadrupled my money. Oh, I would have gone all in because I knew that was a bounce back. Uh-oh. Ah, okay, yes, that's right. Let's see if I can fix that real quick. That will work. Note. Number E, which I said is what we call the natural number. It's the most commonly used base in mathematics. E is what we call a transcendental number.
Isn't that like just like a set number?
Well, it is a fixed number.
Like how pi would be.
Pi is also transcendental. Transcendental generally just means there's a formula to find it. It also happens to be irrational, which means it's a non-terminating decimal. A non-terminating, non-repeating decimal. So you never want to use its approximation. Just use the actual value. Just use the actual key in the calculator when you're working with it. Same thing with pi. The actual definition of the number E, you're not going to really understand because it does require calculus, but there it is. It's the limit as n approaches infinity of 1 plus 1 over n raised to the nth power. All this means is you take this function, this value converges to E as n increases. Right, or if you look at its sequences, which again is calculus, Calc 2, the sequence of all these values will converge to E as you let the number of values increase to infinity. But that's the actual definition of E. Approximately 2.718282, and then it just goes on, and like I said, it's non-repeating and non-terminating. This concept was named by the Swiss mathematician Leonard. I think that's what that is. Leonard Euler. He was the first to investigate and discover many of its properties. In fact, if math has a god, it would be Euler. There's math that hasn't been invented yet that Euler has a theorem in. In fact, I think it was Euler who also came up with a 500-page proof of something. And I know it was Euler in one of his journals who wrote down a property and in the margin said, I could prove this, but I don't have enough space. Want to get shanked real quickly? Walk into a math conference and call him Euler. If you're feeling brave, you can do that. Just make sure you're near the door so you can make it out alive. With this number, we now have what's called the continuous growth function, which is just exponential growth except your base is E. Right. In this case, it does look just slightly different. It's still the same thing. R is called the growth rate, or your rate of growth or decay. So if you have a negative R, it would be a decay, right? So if your R value is negative, let's say it's negative 0.25. Right, that's a 25% decay rate. T is elapsed time. In this case, it doesn't have to be years, could be seconds, minutes, nanoseconds, depending on what you're looking at. And there we go. If R is greater than 0, represents growth. R is less than 0, represents decay. If R is 0, it's very boring. Right, then it's just a constant function. Let's say you throw $1,000 into a savings account. No, we won't use savings account because that's not a realistic interest rate for savings account. Let's say a money market account. You might be able to find a money market account at 5% interest. I found some at 3.25. So 5 is not outside the realm of possibility. Probably more like this is a bond. So 7 years, we're going to calculate how much money the account will have after those 7 years under different compounding scenarios. Right, so the purpose of this problem is to show you the effect of the number of compound periods on compound interest. Right, because generally speaking, you're going to have 3 factors that affect it. Your interest rate, obviously. Right, the higher the interest rate, the better. The amount of time you leave it in the account, which we examine in the next problem, and the compounding periods, how many compounding periods you have. As we're going to see, the number of compounding periods doesn't play that huge of a role. You really look for interest rate and time. Now again, remember the model for compound interest. A of t. See, I'm not going to use that because I'm not used to that. This is what I'm more used to. P of t is p naught times 1 plus r over n raised to the n times t. Again, P naught is just your initial investment. In this case, $1,000. Using the information given, P of t is $1,000 times 1 plus, what's R?
0.05.
N is what's going to be changing in this case. Raised to the n times t. Actually, I should actually write this not as a function of time, though, but as a function of n, because our time is being fixed at 7 years for this entire problem. So I can write it that way. All right, so this model is going to give us, or this function models this savings account under different compounding scenarios. Right, this, let's call it a 7-year bond under different scenarios. Starting with yearly. If we compound yearly, what is n?
1.
It's 1. Remember, n is the number of compounds per year. Right? Or if you will, the number of periods that you gain that interest per year. right? So thinking about stock markets and mutual bonds, you have dividends. I think those are quarterly, right? So that'd be compounding 4. There's another one as well. There's dividends, and then there's, you gain 2 things on. It's dividends, and there's something else that you gain.
Dividends.
I can't remember what it is off the top of my head now. Might begin with a P. But I'm not sure. Why am I drawing a blank? I know this stuff. I study it. Go back on them later. That means what we're calculating is P of 1. We get 1 plus just 0.05, all raised to the 7th power, right? So $1,000 times 1.05 to the 7th. Now, we're dealing with money. So we're just going to approximate to 2 decimal places, right? For this problem, I will use the calculator.
1,407 point, do it, or is 0.10.
I'm going to show you a cool little feature you can do on the Inspire if you have it. You can actually store functions. And so P of n, and you want a semicolon, control, and then right here. Now my function's stored. Which means now I have to do is do this. What was n? 1? P of 1. $1,407.10. This prevents me from having to rewrite the same bloody thing for each different value of n.
So you'd only be getting like $407.
So in the 7 years, you earned $407.10 of interest. Quarterly. I kind of did this one already. If it compounds quarterly, what is n?
427.
N would be 4. Now you have 4 compounds in a year. What we're looking for is P of 4. Four times 7, 28. It would be 1,000 times 4.05 over 4 raised to the 28th power. Or, since we just stored the function, P of 4. 1,415 and 99 cents. How much more did you make if it compounds quarterly?
$8.
Yeah, about $8. 8.89 looks like. Ooh,
So if it was
that's not even a Big Mac anymore.
But if it was so if it's quarterly, $100, 103 for a quarter.
Mhm.
It's 1 3 per quarter, right? If it's quarterly. No.
This is over 7 years.
Oh, okay.
So you have a total of 28 compounding periods.
Okay.
Right? 4 per
I
year
was
for
thinking
7
of 1
years.
year.
You were thinking 1 year.
Yeah.
Which is why the exponent is 28, right? That's the total number of
Okay.
periods you have over the life of the account.
So that's how much you would make at the end of the 7 years?
That's how much will be in the account after 7 years. Not how much you make. How much do you have in the account?
Yeah, so you'd only make like $450?
Yeah, only at $415.99. That's how much interest you gain. Total.
It's dumb.
It's also only 5% a year.
And if you have more than 1,000, it could get turned to a lot.
So when you're talking with things like that, you want to be relative. Yes, it's a lot of money, but relative to what you put in, it's the same.
No, you're right.
Yeah, because like if you, yeah, so like might be only 1,000, right? But even if you put like $5 in or whatever,
Relatively, you'll get the same return.
yeah.
Relative. Yes, it's going to be less, but you put less in. Again, if you put in $1 million, yeah, you're going to be getting more back, but it's also because you put in $1 million.
Yeah. I know what you mean.
Monthly is next. If it compounds monthly, what's n? That means we look for P of 12. And 7 times 12, 84, right? Let's make sure you can see the screen. Right, so we want P of 12. $1,418 and let's call it 4 cents. Let's say that this bank is nice and they round that up. Now this is actually an evil tactic. Gas stations do that all the time. Pass by, how much is it per gallon? They'll be like $2.95 and 9/10 of a cent. It's actually $2.96 a gallon. I don't know why they do that, but how much more did we make compounding monthly versus quarterly?
$2?
Just a little over $2 extra. Is that even a large soda anymore? I think a large soda is more than $2.
It's not even like a medium fry.
Really, medium fries are that cheap? I just went to ShopRite this weekend and got a week's worth of meals for $14 because they were having a sale. That's one McDonald's meal, and it's healthier. Problem is, I had to waste my Sunday making it. Daily.
365. Right? 365. 52.
That's what I'm going to use,
40.
but that's not actually correct. That's also not correct.
So you believe that there's more than 365 days in a week?
That's not a belief, that's a fact. The definition of 1 year is the time it takes for a planet to make one complete revolution around the sun.
So leap day.
It's more than 365 days for Earth to make one complete revolution.
So what's the number?
So you're telling
It's
me
365 and some change, but it's not a quarter.
It's not.
you're telling me my birthday is not the same day every day.
According to the Earth, no. According to the Earth's position in space, no.
So I can celebrate my birthday whenever I want.
No, because if you actually just look at time in terms of the definition of a second, it is fixed. Right, so you're still aging at the same rate regardless. So it has, the rules for leap year is actually fun. The year is divisible by 4, it is a leap year. Unless it's divisible by 100. Then it's not a leap year. Unless it's also divisible by 1,000, then it is a leap year.
Why are you dividing it by 1,000?
The year. Right, so 2000 was a leap year.
Okay.
Because it's divisible by 4, but also 1,000.
Yeah.
The year 2100 will not be. Because it's divisible by 100.
So 2025.
Not a leap year. It's not divisible by 4. Every 4th year is a leap year, except for every century mark. Except for every millennium mark. Because it's not exactly 365.25.
So this year would just be a regular year?
Yeah, this year's just a regular year. Our next leap year will be 2028. That's why I said it's really weird how they did it. Also don't understand why they did 12 months and not 13.
Why 13? It would fit for.
So 52 weeks in a year?
Yeah.
Divide that by 13 is exactly 4 weeks in a month.
I think it should have been you that made that up.
So you could have 13 months and every month is exactly 4 weeks. Except for leap years. Then you get that like extra kind of day. Although I don't think it's exactly 52 weeks in a year either. 365 is not divisible by 52. But at least if we're going to go with the weeks, say 52 weeks in a year, do 13 months. Because 52 does divide by 13, it is a factor of 13.
That's what some months have a longer one.
But what do I know? So doing daily compounders is actually kind of complicated. Because you have to factor in the account of leap years. In 7 years, you're guaranteed at least 1 leap year. You could have 2. So you'd have to do something a bit more complicated in terms of the formula. We are going to go under the assumption that's just 365 days in a year. Because honestly, that extra 1 or 2 days isn't going to really make that huge of a difference. That means we want P of 365. What's 7 times 365? It's obvious. Took you too long. It's clearly 2,555. Well, you don't know your times tables up to 365? What do they teach in school nowadays? So this would be 1,000. 365.05 divided by 365, so 2555. Oh yeah, also, by the way, 1 day, not 24 hours. It's actually less than 24 hours.
That's why it gets dark some days quicker than.
No, that's to do with the tilt of the Earth. So that's to do with the fact that the Earth is tilted. And so as we rotate around the sun, it's tilted, so as it revolves, you do get different lengths of sunrise versus sunset. And it also depends on where you are. The further north and south you go, so there is, my uncle served in Alaska. And where he was in Alaska, there were periods where it was 24 hours of daylight. And then there were periods where it was 24 hours of no daylight. Until, theoretically, if you're exactly at the North and South Pole, you'll get exactly 6 months of pure daylight and exactly 6 months of pure night.
That's crazy.
That's to do with the tilt of the Earth. But the definition of a day is
You mean the axis?
the tilt. Yeah, it's axis of rotation.
Axis.
But I think it's 23 and some change hours. It's how long does it take the Earth to complete one full rotation. The tilt is also a variable. The Earth actually wobbles like a top. So the North Star isn't always the North Star. The North Star actually changes. But that period, I think, is something like 23,000 some years in terms of its wobble, its period of the wobble. So it completes a full wobble every 23,000 something years, something like that. So you won't be around long enough. And the magnetic poles also switch. North Pole wasn't always the North Pole. They also switch. But again, that's so long that it won't happen again in our lifetime. But that's going to be fun in the age of electronics. When the poles switch, it's going to fry everything.
You're exposed to all live right now.
1,419 and let's say 3 cents. I haven't even gotten to the good stuff. Study advanced physics and cosmology and you realize that your life is insignificant to the universe. Your life means nothing.
You believe in the leprechaun?
So question your existence is really what happens. Or are you even alive? Are you real? Does this exist?
There's grades about there.
The government's gonna come get you.
Is the government real?
I guess.
There's a theory out there that this is actually just all one giant computer simulation. Like The Sims and God is the player. You laugh, but it is a serious theory.
No, I'm just laughing because it's just, this stuff is insane. It's like, I'm not saying it's wrong. I'm just saying, like,
Well, we would never be able to know, but
it goes deep. Like, I'm saying these conspiracies go deep.
again, that's not a conspiracy. That is a legitimate theory. It has legitimacy in the scientific community.
No, I believe you.
So,
I just
but that's really advanced physics stuff. So the more you study physics, the more you start to question your existence. And not just why am I doing this to myself, but literally, am I even real? If not, what's the point?
Or what if there's just an individual player controlling all of us?
Well, that's the theory. We're just computer simulation and God is the player.
Not like he got a different person on the outside, I got a different person on the outside, and then we just.
Well, that'd be the multi-God theory. Which personally is the one I described
So
to.
basically, you're saying we all God.
No, we don't exist.
Who comes up with all these theories?
People smarter than me,
I know, but where are they getting all that from?
and people who are very bored, like Einstein,
Yeah.
came up with this theory of general relativity by working in the patent office. Actually stole it from someone too, which is really funny. Going from monthly to daily, an extra buck. Even if we just look at yearly to daily, it's really not that big of a difference, is it? So the number of compounds in a year doesn't play that big of a role. Obviously, the more compounds you have, the better. The more you are going to make, but it's kind of insignificant. Which is why I don't look at compounds when I'm making investments. I look at the interest rate and how long am I leaving it in there. I just still have one more to go over. That's continuous.
But would it continue to be smaller than all of those? Just 2.47? Just 42.
I just realized. No, that is not a math pun either. Why I chose part B to be continuous.
Like you were saying, that it's hard to get 5% account. Even like, it's just hard. There's not that many. Would you say you got one that's
In terms of savings accounts.
money market account?
Yeah, I found a 3.25% one. It's really difficult to find a 5%.
Yeah.
That's a really
Really
good
don't
interest rate
exist.
money markets.
And it's so annoying how like some, if you're just in regular savings, it's like negative.
Yes.
0.
For continuous, what's N?
Oh,
N approaches infinity for continuous. Again, I'm not going to go through all the calculus. For continuous compounding, that's the model. P naught E to the RT.
That's what I need, continuous compound for my investment.
Theoretically, that's what the stock market is.
What do you mean?
Stock market's always gaining or losing, right,
Sure.
throughout the day.
Yeah.
So theoretically, that's what the stock market is, although we, in the investment, will kind of look at it as a yearly compound. Maybe quarterly,
Yeah.
but yearly would be more accurate.
No, yeah, you're right. It is nonstop, all the time. When the market's open, but
That's why I said theoretically it's continuous. It's really not because it has all the bank holidays and weekends where it's closed.
Yeah.
But
crypto could be continuous, right?
no, I think crypto is the same. I think crypto has, because the value of crypto is dependent on the stock market. Right? It's dependent on an exchange, which is stock market exchange. So again, it's not going to move during bank holidays or
I thought crypto
weekends.
never stops, like Bitcoin, like,
Who calculates the value of it?
I have no idea.
Stock exchange.
I didn't know
So
that.
when they're closed, they're not calculating a new value.
I thought that like,
Again, technically speaking, it's always gaining and losing. Everything's always gaining and losing. But when is it being calculated? It's only calculated when stock exchange is open.
okay. Because you're saying there's.
So you're not, so you can't like on a weekend exchange it for a new rate because it hasn't been calculated yet.
Okay.
And they won't even process the exchange until the next
Monday.
the next working day.
Okay.
But don't invest in crypto.
I don't.
Maybe have 10% maximum of your investments in crypto. So it's too volatile.
I don't even put like anything, so I understand it like well enough. I would do it for fun though.
But again, yeah, 10% of your investment in crypto, that's fine.
Yeah.
But you don't want the vast majority of it to be in crypto.
No.
Because it's too volatile.
Yeah. I'm watching all day.
So P of 7 here, 1,000. E to the 7 times 0.05. Would be 0.35. So I think what I'm going to do here is I'm going to do two things. I'm going to use the E button, and then I'll actually use the calculus definition of the limit and compare the answers. And what you should notice is they're the same.
You got the 0.35 by doing
7 times 0.05. Right, because it's to the RT, rate times time. So on the Inspire, here's your exponential button. E to the x. $14.19, 7 cents. Ooh, 4 whole extra cents. Now let me do this, which again, you don't need to worry about. Oh, no! No, it doesn't let me do the limit on this calculator. That pisses me off. That's okay, that's what mathematics is for. T. Actually, it wasn't T, was it? It was N. 1,000 times 1 plus 5 over N raised to 7N. Limit P of N and goes to $14.19.07, and if I do this instead, that's not going to give it to me. Yeah, you suck. Oh, I know why it's not going to give it to me. I can change that. Instead of making this 0.05, I'm going to make this 5 over 100. So it avoids the approximation. There we go. Now I can do it. Compare that to the calculator, and it should be exactly the same. Because this limit is actually how we derive that formula.
So we compound like nonstop for how many years? 7 years, right? And we'll only do that. Damn.
So that again, that's what I mean. This just shows the compounding periods doesn't play that big of a role. It does play a role, but not the biggest role. So you really shouldn't focus on the compounds.
And like you said, relatively, if you have a lot of money, it's not a lot of money, but I know what you mean by that. But if it was like $1 million, it would still get a lot more.
It'd be more than you're getting here, but again, relatively speaking,
Is that, yeah, 'cause I guess it would
It's
be a
not.
lot to you if you had $1 million R&D to put in.
so there we go. Let's go back to. So you can now compare the compounds, right? So everything else is the same except for the compounding periods. Gives you a good comparison of the role that compounding periods play. So again, if you have a choice of investments where everything else is the same, go with the more compounds. But generally speaking, you want to look at the interest rate.
Well, for stocks, there's not really interest rate, right?
You look at the average annual rate of return, which every stock will give you.
Yeah, but it's not like determined like a.
No, but it's still a good approximation.
Okay.
Because again, S&P 500, its average annual rate is like 10%.
Okay.
That means on average, you gain 10% every year.
Yeah.
Yes, some years it's going to be down, some years it's going to be up, but long-term average, you can expect 10 a year.
Okay.
And that's what we use.
You lose all that though if you start investing in like penny stocks, right? Or no?
They still have to provide an average rate.
Okay.
So they have to provide how much on average does it gain a year over its entire lifetime. They still have to provide that. If they don't, then they're not trustworthy.
Okay.
They also have to provide how long the stock or fund has been around. Again, you typically don't want to invest a lot in funds that are less than 15 years because it's not a long track record.
Like a new IPO, you wouldn't invest.
So new stocks, again, you can put some in it, just make sure it's not the bulk.
Yeah.
Because it's not trustworthy, so it could just crash and you lose everything.
Yeah.
But at the same time, it could quadruple.
Yeah.
Right? You just don't know. But the safest are the ones that have long track records, 15, 20, 25 years. S&P has been around for like 30, 35, much longer than that probably.
And the IPOs are fun, but they're risky. They're fun to like go around along with the bandwagon or like the hype, but they're also like could crash.
Let's see if this number is still accurate. Still 7, okay. So, let's actually just look up that as well. Average. Approximately 10%. Okay, that's what I thought, still 10%.
That's why I don't understand.
So this is the maximum amount you're allowed to put into a IRA for tax year 2025 is $7,000. Unless you're 50 or older, then it's $8,000. It's an extra $1,000. So I'm just going to say, okay, tax year 2025. You scrounge up $7,000, and you throw it into an account that matches the S&P 500, which is a yearly average gain of 10%. How much will you have if that account is left untouched after 5 years, 10 years, 20 years, and 50 years?
So annually.
We're going to assume annual compound.
And that would be one.
Again, as the previous problem shows, the number of periods doesn't play that huge of a role. So we'll just go with the lowest.
And that would,
Makes it the simplest.
so in this case, N would be A, B, C, or D.
N is 1.
And, okay. And,
This represents time. How long is it in the account for? And here I'm not going to write everything out. I'm just going to create a table in Mathematica for it. It's just easier. So I'm going to redefine my P function. Initial investment of $7,000 times 1 plus Actually, I don't need 1 plus. 1.10 raised to the t power, right? Because n is 1. That's our function. I'm going to make a table. P of t. T is my variable for the table, and I want several different values. What was it? It was 5, 10, 20, and 50? Yeah, okay, I have 1.10, so it should be fine. So after 5 years, it's $11,273.60. See, I don't like that they're only giving me 1 decimal place.
5.7. Oh,
I don't like that they're giving. So I'm going to fix this. 1.10. 110 over 10. No, 110 over 100. So I can do this and say I want 10 places. Mathematics is weird because that's not 10 decimal places, that's 10 total significant digits. Actually, that's good enough. And so 50, right, so 11,273.57 cents. That's after 5 years. After 10, it's only 18,156. After 20 years, it's now 47,092. But now look after 50 years. 821,735. Let's just say, okay, Precalculus, typically it's a freshman course. Right? Generally speaking, the average age of a freshman is, what, 19, 20 years? Something like that. We'll go with 18 years. 50 years would be 68, retirement age. You come up with $7,000, put it into an IRA. Roth would be the best because that's tax-free. At retirement, you have $800,000 if you do 10%, if you match the S&P.
Pretty good.
I'm about to do that right now.
That is, again, the assumption that you don't touch it, so that means you're not adding anything to it.
I thought it was 7,000 a year.
No, just one 7,000.
Oh, that's it.
So realistically, I'm about to be a millionaire by age of 75.
Oh, I've already done calculations on what I do. Oh, yeah. My account will have well over $10 million in it by the time I hit retirement age.
Serious?
I'm going to be just fine in retirement.
That's great. And like, what age did you base that off of?
65. What was it, 60?
So
When did
say,
60?
so say you were to put
And that's just me, not my wife.
20,
Wow.
if you put
What are you gonna do after that?
$25,000 into the account, right, it would be like way more than that, or like a little more, right?
If
But
I do
you
what?
can't- You can't put more than 7,000,
Or
right?
you can.
In an IRA, you can't do more than 7,000 a year right now. That's the maximum you're allowed to put in.
But you
Why?
can have different ones, right?
No.
You can't just one.
Not IRAs.
And they do
If
that.
you have a spouse, your spouse can have an IRA and then it'd be 14,000. Right? Each of you get 7,000. There's also work accounts, which are different. Right? So if you have a work retirement plan or a pension, that is separate. So you can do the 7,000 in the IRA plus whatever you put into your work. And generally speaking, the work doesn't have, I mean, it has a maximum, but you're not generally ever going to reach it. You're going to have to be putting in almost your entire paycheck every period to reach the maximum. And that's not including if the company matches as well, which is what I get. I put in 5%, the company does 8% because it's a government job. So essentially, I get deposit 13% of my pay into a retirement account.
Why does it limit you to only 7,000 a year?
That's tax rolls. That's just the
Oh,
tax
that's
roll.
why. And when you pull it out, that's when you pay taxes on it, though, right?
That's Roth.
You don't pay any taxes at all.
Because it's post-tax. What you put in is after you pay taxes on it.
Okay, I got you. So you put in 7,000. The
If
taxes
it's just-
charged on the 7,000.
If it's a regular IRA,
Yeah.
you do pay taxes. That's considered to be pre-tax.
That's when you pull it out.
Yeah, so
Okay.
then you pay when you pull it out.
Okay.
On retirement accounts.
Yeah.
If it's just a regular investment, there's no maximum.
Like a
You can
401k.
invest as much as you want, but you have to pay quarterly taxes on the gains.
Okay, I got you.
So like a 401k where like.
401k is work. That's a retirement account. And that stands for the section 401 subsection K of tax law. But Roth is post-tax money, and that is tax-free growth. So you don't even pay on the growth because you already paid on $7,000 on what you already put in.
You maxed out those 7,000, right?
And some workplaces also have Roth accounts as well. Always do that because that's also tax-free growth. But then it comes out after taxes, so you're paying more taxes. Let's do this. Except now let's make it 15% instead of 10%, which you should easily be able to find. Look after 50 years.
It's $7 million.
That's $7.5 million.
So you're
That is just a 5% increase in your annual rate, which again, you can easily find.
Wait, this is the same, this is still 7,000.
It's still the initial 7,000
And it's 5%.
at 15% now instead of
Oh,
10%.
15%.
An extra 5% interest.
Okay.
And again, that's a one-time deposit. That's not including if you put anything else into that. $7.5 million.
But if you already have $7 grand in it, you can't put no more. If you're talking about.
No, per year.
Oh, so you can keep stacking up.
Yeah. And generally speaking, that amount rises, right? Because it used to be 5,000.
Oh, it's 7,000.
It used when I started working, it was 5,500.
So you could, so say like this year, boom, I put 7,000, and next year I put another 7.
Tax years end in April. So you could theoretically in 2026, in March, put it in and then choose that you want to put it in for tax year 2025. As long as you put it in before April, which is the end of the tax. But you can only do 7,000 a year. Until 50, then it's an extra 1,000 a year after that.
You said you calculated yours to about 10 million.
Well over.
So how does that work though? Just one account?
Because it's my retirement account. But I'm calculating it using the formula where I'm putting money in every year.
Okay. But that's not.
That requires calculus.
But that money that you're putting in every year is not all going into your Roth, right?
Oh no, that's just my work account.
Okay.
That's just my work account. That's not any personal
Okay.
investments that I make. Plus, that does not include what my wife does.
Okay.
And my wife's going to be a nurse practitioner soon.
Okay.
She makes a lot more than I do.
Really?
When she's done, I'm going to be handling her investments as well. I'm going to tell her how much to put in. We're going to be just fine.
Good.
This also isn't counting anything that I get from Social Security.
Okay.
That's just icing on the cake.
So you're saying you're gonna have, when you retire, and all of your.
And what you want to do is you want to live off of 10%. So ideally, just live off the growth. Don't touch
Why
the
does no
principal
one else do this though?
because it's not taught.
Like, I'm saying teacher, like, I don't see that many like that.
Even a lot of finance courses tell you to take out debt. Don't take out debt. That's the biggest wealth killer is debt.
I mean, these seem very, like, financially smart.
I'm not saying.
But I'm
I'm
not
not saying I work.
I mean,
as
I
not-
wasn't because I took out a lot of student loan debt. Other than, again, I'm also in public service, so I would be forgiven. Thank you, by the way, because that's at your expense. Taxpayers pay that. So thank you, by the way, I appreciate it. I will have to write that off. Oh, yeah, oh, no, I don't. Public service forgiveness, I don't have to write off.
'cause a lot of teachers.
So that's also something they don't tell you. Right, so remember when the idea was floating around of just paying off your student loans? Here's what they didn't tell you. That's taxable income. You pay taxes on that. So if they forgive $100,000, you just gain $100,000 in income. You pay taxes on that. Surprise! You go file a tax and they come back, you owe $25,000. Surprise! That's still better than owing, $500,000, but if you're not expecting it.
Yeah, but then
If you get credit card companies to forgive your loans, that you have to report as taxable income. Surprise.
So if you get like 100K forgiven, then you're paying taxes on that 100K.
That goes into income.
Damn, I never do that.
So it goes into your what your taxable income is. So if you make $50,000 a year and you get $100,000 of loans forgiven, your income for that year is $150,000,
Wow.
and you pay taxes on
Still
that.
better off though, I guess.
It is, but if you're not expecting it,
Yeah.
it's a surprise.
Yeah.
If you are expecting it, you can start to set money aside.
Yeah.
Now, there are some exceptions. So again, my public service loan forgiveness is non-taxable.
So some are non-tax.
Because, again, it's a government benefit. I am technically a state government employee.
So they won't tax you on your forgiven loan. Okay.
So there are few exceptions to that rule, but for the most part, anything that's forgiven is considered to be
So
income.
basically, you're saying I can become a teacher just for that benefit and then quit being a teacher.
It's 10 years.
Gosh.
Well, 10 years of qualifying payment service. And then you also have to go through the process and it's government. So that could be another 10 years. Government's very slow. Unless you owe them money, then they're pretty quick.
Yeah.
If they owe you money, they're very slow. I'm still fighting 2
You're still
years
being
later
audited?
for my tax return.
You're still being audited?
No, the audit's done.
Oh, it's done.
My tax guy's now fighting it back, saying that they're wrong.
Who's fighting back?
My tax guy.
He's fighting back.
That's why I pay. That's why I pay him, so I don't have to deal with the IRS.
Yeah.
He's my power of attorney right now for this. That's why I pay him. Worth every $300 a year.
You beat the audit case or whatever?
Because I don't have to deal with the IRS.
I mean,
And if it turns out he made a mistake, he owes that money, not me. Wow. That's why I pay. Don't do your own taxes, it's stupid.
Terrible tax.
Let's do what I average, 22%. I've been averaging 22% a year returns.
you must be the most right investments.
Because you just like, you got some like celebrity type of bread. Damn.
No, it's just I'm a number person, so I enjoy looking at all the investments and their returns and everything.
No, for sure.
I enjoy it,
I'm not really.
which is why I'm thinking about going to grad school for finance and accounting.
Should. Could be on Wall Street by now.
That is 145 million,
Is that 122% or 22%?
22%, which would be 1.22 to the T.
This is just saying what you've been doing for about.
So this shows two things. One, the power of time. Invest early.
This one I'm never selling.
Two, the power of the interest rate. Look at the difference between 10%. Well, let me highlight it anymore. Between the 10% and the 22%.
Why is the interest so high in 22? Because it's your earnings?
Because,
It's you.
no, because, so I average 22% returns every year.
Because you're not mimicking though. This is you actively looking, pulling.
Because I investigate it regularly on what I'm earning.
Okay.
And they also give you lifetime. Since I've started really seriously doing this, I've been getting between 20 and 25% return every year. 1 year, I was down 20%, and that was 2020. No, I'm sorry, 2021. When the stocks were down, when the entire stock market was down.
Yeah.
Every other year, I've been up 22%. I've beaten the S&P every year. I've more than doubled the S&P every year.
Great.
And that's just because of the vast majority. I don't just invest in one thing either. I invest in several different things. And if you average everything together, it's about 22% a year. 1 year, like I said, I made like 28% a year in 1 year. That was awesome.
And you,
I would have made, what, 200% in 2020 if I had the money?
and you do like do any individual stocks or just?
No, I do mutual funds.
Okay. So you're not.
I'll do individual stocks when I have a bit more money
Okay.
that I can play around with. Then I'll do individual stocks. Otherwise, it's mutual funds. Again, mutual funds are your safest bet. Then when you when you have the cash, you can do individual stocks. But again, put like all those high risk things, individual stocks, crypto, gold, anything that would be considered to be extremely high risk, volatile, that should be no more than 10% of your net worth. 10% of your investments. No more than 25% of your net worth should be in a car, because cars decrease in value. Anything that decreases in value should be no more than 25% of your net worth. Your home goes up in value, that's part of your net worth, so that's fine. And generally speaking, it's always going to be your largest investment.
You consider your home an asset or not?
Not the value.
Yeah, if you're living in it.
Doesn't matter, it's still an asset.
Yeah.
That still goes into your net worth calculation.
Yeah.
Because when you die, your kids get inherited, they can decide to sell it.
That's true.
So it does go. Net worth is what you own. That's everything, including TVs. So it's your assets minus your liabilities. That's your net worth.
Okay.
A lot of people have a negative net worth because of student loans and such.
Yeah.
And then you want to, like I said, you want to just live off the growth of the investment. You don't want to touch the principal. So if I'm gaining 22% a year, let's just say I have $1 million. What's 22% of $1 million? $220,000. At retirement, if I have $1 million making 22%, I have a $220,000 annual income to live off of. And if you just imagine you have no bills,
It's way better.
just your utilities, but no mortgage, no student loans, no credit, nothing, and you make
It's almost better
$220,000 a
than
year.
doing like market accounts like ETFs and mutual funds because the stocks just like. aren't-
Now imagine you have 145 million at 20% a year. 10% of 145 million is 14 million. I think you can live off $14 million a year.
I mean, that's what people with a ton of money like that do. If I just put it all in stuff like that and just sit around.
I mean, at that, I'd be buying extra properties. I'd have a lake house. I'd have a mountain cabin, somewhere that no one knows about.
I mean, property is a great way to go. It doesn't really.
Because that's also going to go up in value, so
Yeah.
it's still a good investment.
Yeah, for sure.
That's why this is probably my favorite day of the semester when I get to teach this.
This is my
If I've
this is
encouraged
my
you to
favorite
invest,
class.
I've done my job.
It's my favorite class so far in pre-calc, whole course so far. 'Cause I love talking
Now-
about it.
Again, this is all just approximations because when you do retirement accounts, you have up years, you have down years, right? So, but this is a pretty good estimate. Let's say I'm half wrong. Half of 145 million is still over $70 million that you have. Let's say I'm a tenth, I'm 90% wrong. You still have over $1 million.
I also feel like,
You're in good shape.
if you're down on like blue chip stocks, like if you just wait, you'll be alright.
No, so what's the saying? It's one of my favorite sayings. The only people who die on a roller coaster are those who jump out.
I like that. I'm down right
Because
now.
stock market is a roller coaster. It has up periods, it has down periods. You're only going to get hurt if during the down period you decide to try and get out, because now you just lost money. You don't actually lose money until you sell it.
Yeah.
So everyone who goes, oh my god, I just lost money in the stock market, you just look at them and go, did you sell your stocks yet? No, then you didn't lose anything.
Yeah.
Stay in it. Buy low, sell high. So again, in 2020, I knew that was an artificial low. That would have been the perfect time to just throw everything you have into it.
Like right now, kind of low too.
No, it's not.
No.
It's top. Well, it's down for the year so far, but it's still pretty high.
Relatively speaking.
I'll look, my watch is done again. I need to take this in.
No, I'm be better off holding for years than selling and losing.
Just hold.
Yeah.
Hold. Even in retirement, just keep investment accounts. Give them to your kids. Or be really spiteful. Like I'm gonna do. If my kids ever get into drugs or anything, they don't get a dime.
That's
It'll
valid.
all go to charity.
That's a good argument. Do something else.
It's not their money, it's my money.
It's true.
They want it, they're gonna have to work and earn it. And they're gonna follow my rules. Again, another favorite saying. Even if I open up an education account for them to go to college, that's my money. No. Well, yeah, legally it's yours, but good luck. I have more money than you. My lawyers will last longer. So legally it's your money. Realistically, it's my money. You follow my rules, or you don't get it. That's how this works.
What if one of them just becomes like a famous YouTuber and just gets like way
I'm entitled to a part of it because I rose them. I spent 18 years raising them. They wouldn't be that successful without me. Now for the not so fun stuff for you.
Then we're back to the normal.
But for me, again, this is still enjoyable. Simplifying expressions. All right, so we're going to actually work with some exponential expressions and simplify.
You gotta open up finance class here at Mercer.
They have some.
No, I know, but like, you gotta open more.
I don't have a degree in it, so I'm not qualified.
Yeah, I'll join it.
Honestly, I would actually not do that full time. I would be a full-time accountant. Then you back feel good.
Be a good CPA.
Remember, what you're going to need here, because we're now dealing with exponential functions, remember your laws of exponents from algebra? They're all going to come back. Raise a fraction to a power, it's the same as raising both numerator and denominator to that power, right? So that's what we're going to do here. Expand out the first numerator. That would be binomial. It's not actually a binomial, but we're still kind of called that because it's two terms. Squared. Square of the first term. E to the x squared. What happens when you have a power raised to a power?
they cancel. They double.
Is it after multiply?
Multiply.
Um,
It's add if you're multiplying base.
The base. Okay.
Same base, different powers, then you add the powers.
Okay.
When you're taking a base to a power raised to a power, you multiply the exponents.
Okay.
So e to the x squared is e to the 2x.
so you multiply.
Twice their product. So what's e to the x times e to the minus x?
Forward.
Same base, or you do the powers?
You add them.
What's x minus x? What's e to the 0?
Oh, 1.
Double it. E to the negative x squared. E to the minus 2x. There's your first fraction squared. Second fraction, well, it's identical except instead of plus, it's minus.
So it'd be E. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2.
There's your second fraction expanded out. Same denominator, so we can write this as a single fraction. E to the 2x minus e to the 2x. E to the 2x minus e to the 2x. E to the negative 2x minus e to the negative 2x. 2 minus negative 2. That whole thing is 1.
Everything?
That expression is 1. That expression equals 1.
How'd you get 2 again? Numerator.
Twice the product
What's the product of it?
of your terms. Right, so remember,
Oh, because you
it's
combined it.
so it's a plus b quantity squared.
Okay,
That's a squared plus 2ab plus b squared.
okay.
So you just take the product of the terms and double it.
Okay,
So again, their product is 1, doubled is 2.
okay.
Or you could do the fourth if you don't remember that formula. And you'll still get 2. So that was cool. That's just 1.
It's gonna be the same thing.
Yeah.
I agree the numerator is going to be the same.
It'll be 1.
So that's a good catch, right?
That's 4.
Yeah.
Because the numerator is exactly the same as what we just did.
Yeah,
The numerator of what we just did.
so it's gonna be 1.
What was the numerator expanded out? 4.
It'll be 4 over.
Right. So we already did that. So from above, that's going to be a 4 in the numerator. Just expand out the denominator. Well, e to the 2x plus 2 plus e to the negative 2x. So it's 4 over that. However, that's what I wanted to do. No, it's not. Okay, so I'm not actually going to expand that out. And there's a reason for it. You're not wrong if you do. We don't like negative exponents in the denominator. Well, actually, in general, we don't like negative exponents in fractions, because that is a compound fraction. You can't because it's attached by addition. Well, factor out an e to the negative x from what's inside that square. Factor out an e to the negative x from e to the x. What are you left with?
Yeah. Exactly.
So if you distribute through, what do you do to the terms? Factoring out's the opposite. So when you factor something out from a term, you're dividing the terms. So you're looking at e to the x divided by e to the minus x.
Is it negative?
What's the rule when you divide same base? What do you do to the powers?
Subtract.
What's x minus negative x?
1.
Oh.
Minus
2x.
e.
It's 2x. Plus 1, all squared. That square distributes to each term. Say distributes, right? You raise a product to a power, each term gets that power, right? So the denominator can be written as e to the negative 2x times e to the 2x plus 1 squared. 4. Now, because the negative exponent's attached by a multiplication, you can now bring it up as a positive exponent. And as a general rule of thumb, we don't expand the denominator unless it's to our benefit. There's no benefit in expanding it out. Nothing's going to simplify, so just leave it.
And what's the formula, like, what's this for?
Oh, it's just simplifying. So it's just algebra. which may be useful. Well, I can guarantee will be useful in calculus, and will most likely be useful later when we start solving more complicated exponential equations. Because we're going to do a real basic one right now.
1, 0.
Yep. Which means set equal to 0 on top. E to the negative x is common, right? Factor it out. What are we left with? X minus 1. The 0 property. At least one of the terms has to be 0. What's the range of e to the x? Range.
What do you mean? What is range mean?
Outputs. What can e to the x equal?
All real number.
That's the domain. What's the range? Look at the graph. What are the y values? What do we say they were?
Oh.
Oh, because it's moving continuous to the right to infinity.
What's the range?
Y to 0.
That's the asymptote. What's the range?
0 point infinity.
0 included?
No.
So can e to the negative x equal 0?
No.
Means that statement's not true. Or you could just divide both sides by e to the negative x because it's never 0. That means this only means one thing. X minus 1 is 0, so what's x? X equals 1 is only 0. That is something you're also going to now need to remember. An exponential function, the basic exponential function, is never 0.
No matter what.
No matter what. And that's because the base is non-zero. God, time just flew by.
It's because we had that finance lesson.
That is true.
So your next project should be posted. Remember, it is, again, different groups, possibly, so you have to check what your new group is. I actually forget what this project is.
Was it about candles?
No, that was the polynomial one. That was the last one. This one I know is on exponential, I just forget the exact thing. Oh, I think it's temperature of coffee. Yeah, it's about Newton's law of cooling, which is exponential type of function. So it's about Newton's law of cooling, that's right, hot coffee. Sadly, they didn't have any investment projects.
Damn.
So that would have been fun.
Yeah.
But again, Newton's law of cooling is going to teach you something new. It's a physics type thing. So that's now up, and that will be due on March 26th. And don't forget, next week is the last week before spring break.
Love to hear that.
So we're going to have a week off coming up.
Do you know off the top of your head when the next test is? 2 weeks after spring break?
Well, I forget.
Okay.
It's meeting number 20.
Okay.
Whatever that happens to be.
So this
Right, so it won't be week 10, it'll be week 11, I think.
oh yeah, so I think that's
Right, because week 9 is like spring break, essentially.
okay.
Right, you lose a week because of spring break. But meeting number 20 will be the second exam.
Okay.
And this was meeting number 13, so. Have a good weekend. Monday we look at the logarithmic function.